Guys, how's it going? So in this tutorial I'll be showing you guys how to calculate the planar average electron density from a cube file. So as you might know that cube files are a quite popular format to store volumetric data among many quantum chemistry softwares. I think it was originated by Gaussian. So essentially in a cube file you can have quantities like electron density, electrostatic potential, or even your wave functions, so molecular orbitals, HOMO orbital, LUMO orbital, and so on. So yeah, this tutorial assumes that you already have generated a density cube file. For example, here on my desktop, I have this density cube file for the H2O on LiH system. So here you can see the visualization. So I have an H2O molecule adsorbed on the LiH001 surface. So let's say I have that, and now I want to see the planar average, or planar integrated rather, electron density along the z-axis. So my assumption would be that I will see a peak like this, then another peak like this, and then a small peak at this point. So let's see how can we do that using a web app that I created actually. So like always, we'll head over to this trippertools.turbomole.org website, and then you will look for cube processing and click on it. So once you are here, you will click on this visit cube suite website, and you will be taken to this new URL, and here you will have this option of planar average of cube file. So just go ahead and click over there, and although it is called planar average, actually in literature people also refer it to as planar integrated, which makes more sense considering this equation. Perhaps if you divide it by 1 by a, that would be the area along the x and y plane, then maybe you can also call it planar average. But yeah, so technically this tutorial is about planar integrated electron density plotting. So yeah, so so let's say you are here, and then you will go, and so basically what this app does is it will take your electron density, it will, for small increments along the z-axis or whatever axis you specify. Let's assume that here we are going along the z-axis, so that would be in this z direction, right? So so what it will do is it will integrate the electron density along the x and y plane. So that's why you have dx dy. And then for different increments in z, so for small increments in z, you will have an integrated electronic density along the xy plane. So yeah, so that's how it works. So let's go ahead and upload this density cube file that I have. And by the way, I would like to mention, so this web app cube suite actually has a lot of fun cube processing tools. So you can subtract two cube files, you can add two cube files, you can expand a cube file, so you can make a supercell out of it, or you can translate a cube file even. For example, here my H2 molecule is not at the center, so I can even translate it along any of the axes to whatever position that I want. So yeah, it's a really fun tool. And actually in the backend, it utilizes this cube tools GitHub repository or library by Funky Monkey Tools. So yeah, so I will definitely recommend you to check that out, because that is what this web app is built on. So here you can do things with command line, while with my web app you can do it via a GUI or a user interface. So yeah, so let's go ahead now that the cube file is uploaded. So let's go ahead and select the axis. So as I said, I want to see the planar integrated or planar average density along the z-axis. So let's go ahead and calculate this. So it will take a moment or two. So here it is. So now what you can see is that you have this for different increments in z, you are getting a planar average density, so as I mentioned. And then what you can simply do is you can plot that, and here is the resulting plot. So it really makes sense. So first of all, you have the first layer of the LiH, then you have the second layer of LiH, and then you have a small peak corresponding to the H2 molecule higher up along the z-axis. And by the way, it also gives you the integral of the cube file, but this is not an exact process, because it will depend on the resolution with which your cube file was generated. So for example, here it says that the total number of electrons after integrating the planar average density is 266.34, and I calculated that my system has 64 Li atoms, so that will give me 192 electrons. Then I have 64 hydrogen atoms, so that will give me 64 more electrons, so in total 256. And then I have 10 electrons from the H2 molecule. That gives me a total of 266 electrons. So this is pretty close. Again, it's not exactly 266 because it depends on the resolution with which you generate your cube file. And by the way, you can also calculate it along any other plane, let's say the x-axis plane. So let's go ahead and calculate that. And before we look at the graph that we get, let me also help you with generating an intuition of what you are going to expect. So what you'll be expecting along the x plane is you'll get a peak right at the origins, like starting from origin, and then it go down, then you will get another peak, and this time this peak should be slightly higher because you have the H2 molecule, and then you will go down, then another peak, and these peaks should more or less be equal to each other in intensity. So let's go ahead and see what did we get with the web app. So yeah, so here it is. So yeah, again, we see that this time the total number of electrons integrated by integrating the planar average density is slightly off, but that is because perhaps along the x-axis the resolution was not that fine. However, if we integrate the entire cube file, then we are still getting 266.34, so it's all right. And here is the plot of the planar integrated density, and here, as expected, it starts with a peak at the origin, and then you have a slightly higher peak compared to other peaks due to the H2 molecule right at this position. So yeah, that is it for this tutorial. I hope you guys enjoyed it and learned something useful from it. In case you did, then don't forget to hit the like button and subscribe to my channel for more videos like this. Thanks for watching and have a great day.